Today you are not doing exercises as practice. All I am sorting out is you're supposed to have covered probability in year 9, but I don't know what you did in year 9. I don't know who you had, and I can't make that assumption. I need to make sure that you have the assumed knowledge about sample space so that we can start on actual year 10 material on Monday. So we're just going to get the notes down. If you know what I'm already talking about, just listen, don't get it down. But if this is unfamiliar to you, then this is making sure that you're all on the same page. Because your last topic is on probability. We'll finish it in about 2 weeks. That'll be your last test. And then I'll be giving people a head start on year 11. Mainly focused on the methods, kids. Because general maths is basically the same as year 10 maths. And essential maths is telling the time. That's the level of maths that is. So, by definition, you need to know what a sample space is. The sample space of an experiment is all of the possible outcomes. If you don't know what that is already, get that down. I'll leave it for a minute to write this sentence. The sample space is the full set of possible outcomes of any situation we're dealing with. And there's many possible situations we might deal with. So in year 10, you are expected to be able to represent sample space in 4 different ways. A list, a grid, a tree diagram, and Venn diagrams. Because this is year 9 work, you're not going to practice this. All you're going to get is these notes on your cheat sheet. If you want practice because you can't handle it, you ask me and I'll give you some material to practice it. So what I'm expecting today is, after these notes are down, there's no practice. You're working your TED Talk. But I need to be able to say, and it's being recorded, it's going to be on YouTube, that I've taught you what you need to know for year 10. So what is a list? So we're just going to get down to here for now. A list is simply indicates all possible outcomes in something called set notation. This simply means you put the outcomes in a curly set of brackets, separating all outcomes with commas. So can you imagine this? I have a disk, and I've split it into 4. And there's 4 different colors here. That's called a spinner. Can you imagine that I'd spin it and then it would land on a particular color? What is the sample space of this? What are the possibilities? Color-wise. Red. No, I asked for the
blue, white.
Yes, red. Red. Oh, sorry, I'll make it thicker. Red is a possibility, separated with a comma. Blue, separated with a comma. White, separated with a comma. Magenta, whatever you want to call it. I would have called it purple. It doesn't matter. It's just an example. Try to draw that as best you can. Based on that, if I asked you to list the outcomes of a 6-sided dice, what would I put inside curly brackets?
1, 2, 3, 4, 5.
Separated with? If I asked you to draw the sample space of flipping a coin, what would I write inside the curly brackets? Good. Okay, so you get that. You get how to list something. If you don't get how to list something, star that down. If you get it, you've got that signature look of superiority on you, but you forget it in the test and you didn't copy it down, that's on you. I'll keep that there. We'll look at grids now. What is a grid? A grid or an array is an efficient way to represent the sample space of an experiment that involves 2 aspects or outcomes to it. Each axis in the grid represents options for each operation of the experiment. Each point on the grid represents a possible outcome. So I've drawn axes for a grid now, but the experiment is flipping a coin and rolling a 6-sided dice at the same time. Which of these axes do you suggest would suit representing the coin flip? The Y. Why is that? What is telling you that? There's 2 options. So we will label this as the coin. And what would be beside these two?
Heads and tails.
Good. Heads, tails. And so obviously the dice is going to be represented. See, this is the second aspect of the experiment. And what are the possible options for rolling the dice? 1, 2, 3, 4, 5, and 6. And where's these dots that he's talking about? This dot represents what outcome? Yes?
Flipping the coin, landing on tails, and getting a 1 on the die.
Good. That's what a grid is. Okay? So get that down if it's not familiar. However, what I'm going to, just while you're getting that down, I'll start asking questions about at a year 10 level. Because, yeah, that's easy enough to say that this was getting a tails and flipping and getting 1. But the kind of questions that you're going to do in year 10 is, what is the chances of me getting heads and an even number? Am I just going to circle 1 dot? What would I be circling to represent the possible outcomes of getting heads and an even number? Where would this is my arrow. I'm here right now. Where would I move it to?
2 heads.
To
In the heads.
heads. Yep. What else?
4 in the heads.
4 heads. 6 heads. See, it's more complicated than that. How many outcomes are there? There's 12 outcomes. 3 out of the 12 outcomes is what I want. So you've got a 25% chance of that happening. That's why this is assumed knowledge. You need to understand this so that we can actually do the maths of it. Okay? Get the grid down if you need. I'll go into a tree diagram now. Tree diagrams are used when an experiment involves more than 2 operations, because at your level we're not going to draw any more than these 2 axes. So more than 2 operations or steps to represent all outcomes. So use a tree diagram to represent the sample space of flipping a coin 3 times. So we're going to write something like flip 1. And the tree starts here. What are the possible options when you flip a coin? Heads or tails. So on flip 1, I could have flipped a heads. I could have flipped a tail. But after I've done that, on flip 2, after I've flipped a heads, I could still get heads or tails. After flip 1, I could still get heads or tails. Can you all see why this is called a tree diagram? It's spreading its wings, all right? It's spreading the branches there. And after, for flip 3, what should I be drawing here? How many branches out of each of these in flip 2? 2. So I'm not going to, I need to thin it out. HT. HT. I haven't taught you this yet while you're getting it down. I haven't taught you this yet. This is where we're heading towards, but I'm just curious for myself. Okay? What would the chance of getting this be?
50%.
So 0.5?
Yep.
Does anyone happen to know how you would work out the chance of flipping 3 heads in a row? What would I do? What maths would I do? You? Times?
0.5.
Yeah. Okay, so you have an idea. If I wanted to get heads 3 times in a row, I'd go, what is the chance of this times the chance of getting this times the chance of getting this? That's year 9 level. But the questions that you're going to be asked here is, what is the chance of you flipping 1 head and 2 tails? Is that as easy? 1 head and 2 tails. Are there multiple branches that we would achieve 1 head and 2 tails?
Yeah. Oh,
Let me draw them. The most obvious one would be 1 head and 2 tails. And the chance of that happening would be 0.5 times 0.5, so 0.25 times by 0.5, so 0.125%, 0.125, so 12.5% chance. But is that the only way
No.
that you can... What's the branch? Where do I go? Down, up, down? You tell me.
Down, tails, heads, tails.
See how that also meets the requirement that we're after? What's the chance of that happening? Still 0.125. What is the overall chance of that happening? Add those together. Okay? That is the year 10 level, but...
And then there's one more.
Oh, there is... whereabouts?
Then there's tail, tail, head.
Yes, you're right. So that was just for my curiosity. I think this topic should be a breeze for you. Let's cross the T's, dot the I's, okay? I'm not going to skip over. I'm going to teach it anyway. Lastly is Venn diagrams. Have you seen diagrams like this before? You may have seen Venn diagrams in this situation where you had 3 overlapping circles. People talk about memes and stuff like that. But here, strictly speaking, a Venn diagram is a kind of graph that represents sets of numbers. The most common Venn diagram we deal with in maths has a rectangle and multiple circles inside. The rectangle is the universal set. That's everything. And everything within it can be grouped further. Have you done practice of this previously, or is this the new one? You definitely did. Good. So you can help me out then. The universal set of all of these is the numbers 1, 2, 3, 4, 5, and 6. But in A, the set A, so U is the rectangle. Let's make A this circle. Let's make B the right circle. How would I place the numbers to tell me this story? What number is in both sets A and B? 1. So where would 1 go?
Intersect.
Where would 2 go?
A.
Only in A. Where would 3 go?
B.
Where would 4 go also?
B.
Do we have the universal set written yet?
No.
Where would 5 and 6 go? 5 and 6 somewhere there. Okay, you get it. Okay. B, let's try to make it trickier. A has 1, 3. Oh, I forgot to write you. A. Where would I write the 1?
A but not B.
1. Where would I write 3?
A and B.
5.
A and B.
Where do the remaining numbers? Oh, sorry. 5 was it?
Yeah.
Where do the remaining numbers
2, 4,
go?
and 6 go outside.
Last one. A, 2, 4, and 6. B, 3, and 5.
A, 2, 4, and 6, B, 3, 5, and
And universal set is 1.
Universal set is 1. And
And
B
3.
has 3 and 5.
Yep.
You wouldn't get full marks for that because should there be a union between these circles at all? There's no crossover, so they shouldn't be crossing over. So you would have to resize this or at least have them separate. Okay, as long as they're not touching, you'll get your marks, okay? I believe there's one question in the test like that. I didn't resize it properly to get the 6, so. Right, does that resemble what the thing is showing? Okay, if you're confident with that, don't get it, I'll leave that up. If you want a refresher, get that down. There are no exercises of this. This is just making sure you've got assumed knowledge for us to start fresh on Monday. What I suggest that you do is you work on science until the end of the day. You need to make sure you upload your supporting slides and scripts to your task.daymap so I can pre-download it. So on Monday, when your name is called, I'll put it up on the screen for you. And you'll use...
Do we have that slides and script?
Okay.
Normally I do script. I do it best when I just have dot points and go on that.
Some of my more successful.
And
The slides are...
So
See, I don't think my 12 would not work.
My topic is about how. It's about how. It's about what.
when you said that,
My topic is about.
Because then it would just be like inspirational photos.
why would I try
Yeah,
to
that's
just
what I'm
be
thinking. Have
dense?
that That's stand on the table.
Ask me.
It's only this
my
side. You
tab.
have to like stand. You have to stand on the table and draw it.
Oh, it's on the
Just for the future.
It's on the white bit there. Okay.
What do you mean?
Question?
Someone was filming with the
Are we getting graded on like the quality of the PowerPoint?
No, your grade is from your presentation. Your what you
Over there?
Okay.
Yeah, look
Big
at
old
the
ding.
like.
Wow.
There's also-
We're all
there's
looking at it like this is some sort of like
Oh.
Nat Geo
Gullible.
Well, it is.
See, that's not what I'm saying.
His phone is being
Like in the car where it's coming out.
That's my father already. Man.
No, I still have to cry if I did. It's horrible.
I thought you meant on
Maybe they do it like on the screen.
My culture is not going to cost me.
I don't know what kind.
You have to follow the Reddit.
Oh, but you've been following the Reddit.
Yeah, you're following the Reddit.
I hate the Reddit cat.
What?
We've got a little red anarchist here.
Ew.
No, it doesn't at all. Why are there three scrubs? And why are they on small houses?